Hey guys, so for this mini lesson, we are going to be working with improper fractions and mixed numbers and what do they mean and how to convert. And so this particular one is going to be converting improper fractions to mixed numbers. Just a quick definition, a quick reminder that numerators is the top number in a fraction, and that's how many parts or pieces that you have. Denominator is the bottom number in the fraction, so the number of parts or pieces that equal the whole. For example, if I had 2/3, so that meant I have 2 as my numerator, so I have 2 pieces out of the 3 pieces that make the whole thing on the bottom. So what does an improper fraction look like? Well, if the fraction has a larger numerator than the denominator, for example, 5/3 or 9/4, then you can see that the top number is bigger. That is what we call an improper fraction. So if the top number is larger, improper. If it's normal fraction, it's just a regular fraction, that means the numerator will always be smaller than the denominator. So since it's the other way around, that's why it's an improper fraction. So what exactly does this mean if I have 5/3? And so, before I do that, what does a mixed number look like? And so a mixed number is made up of a whole number and a fraction. A whole number is like the 1 in this particular example, and the 3/4 is a fractional part. So mixed numbers have both parts. They have whole numbers and they have fractions, and they're mixed together. So that's a good way to help you remember how to do that. Okay, so let's model. So we're going to figure out exactly what 5/3 means, or 5/3, as well as 9/4. And so I'm going to kind of draw like a little quick model right there. Okay, so let's go back here. And I'm going to open up Canvas. Canvas is a free app. It's canvas.apps.chrome. And that allows you to write right on the screen. Okay, so we're going to go back to what this looks like. So 5/3 is our first problem. And so 5/3. What this means is that I have 5 pieces out of something that's broken into 3 pieces. So let's draw that out. So maybe this is a candy bar. Maybe it's, I don't know, anything that's a rectangular piece here. All right, piece of something. And we know that this right here tells us that we need to put it in third pieces. So I'm going to go ahead and just kind of divide this up. And I'm drawing with my fingers, so it's not exactly perfectly equal, but we can pretend that it is. Okay, so there's my third pieces. And this number tells me that I have 5 of them. So 1, 2, 3, 4, and 5. So 5/3. So if I'm writing this as a mixed number, I'm going to write this with a whole number and a fraction. And we know that this right here is one whole because it's the whole thing. Over here, we only have 2 pieces out of the 3. So to write this as a mixed number would be 1 and 2/3. Okay, and this is equal to that. Okay, let's go ahead and do our next example. The second example, I believe, was 9/4. And so I'm going to open up a new drawing here. And so 9/4. Top number, once again, tells me how many pieces I have. The bottom tells me how many make a whole. So in this one, I have 4 pieces that make a whole item. All right, and I know I have 9 of those pieces. So I'm going to break this up into 4s. I can do this lots of different ways, but I'm going to go ahead and do it this way for now. So there's 4. 1, 2, 3, 4. But remember that I have 9 pieces, right? So 4. So go ahead and draw another one. All right. 5, 6, 7, 8. Oh, I still need another one because I still got another piece left over here. So I'm going to go ahead and put that up as well. So 4, 8, and 9 pieces. So what does this look like as a mixed number? I have 2 whole items. There's 1 item there and 1 item there. So I have 2 whole items and 1 out of 4 of another. So 2 and 1, 4. Okay. Easy, right? All right. So coming back to over here, what does this look like? So that's one way to do it. You can actually like draw a model to kind of help you understand what it's talking about. Now, some of you are like, this is awesome. I want to do models. I love models. And some of you are like, okay, can I just reason this out, or can I do it with just numbers? Well, there is an algorithm that will kind of tell you that you can do this with just numbers. I'll show you how that works. Now, it doesn't matter to me which way you choose, just as long as you have a way to do this. All right, so using our same example as 5/3, because we already know that we said 5/3, we already know that that said 1 whole and 2/3 left over. Okay, if we're going to do this with an algorithm or just numbers, we know that the fraction bar means to divide. So this is the same as saying 5 divided by 3. So if I was writing that as a problem, I would write 5 divided by 3, just like I read it. Now remember, we always start in the house when we're writing the numbers. We always start inside. Okay, so let's divide like normal. 3 goes into 5. How many times? 1. 1 times 3, 3. Subtract. 5 minus 3 is 2. All right, so what do we have left? We have 2 out of 3 pieces left. So 1 and 2/3. And that's the same as we got with our model. So we know we're correct. Okay, let's try that again with the next one. So the next one was 9/4. Okay, and so I'm going to kind of erase a little area over here so I can have some more room. Okay, so 9, fraction bar once again means to divide. So 9 divided by 4. Okay, 4 goes into 9, 2 times. 2 times 4 is 8. Subtract. 1 left over. We have 1 out of 4 remaining, so 2 and 1, 4. And if you notice, that's exactly what our model said, 2 and 1, 4. So there's 2 ways that you can try and figure these out. You can draw a model first, or you could do it with an algorithm. Some of you are going to be able to look at this and say, okay, well, I know that 4 goes into 9 2 times. That's 8, and I have 1 left over. So 2 and 1, 4. So some of you are also going to be able to reason this out and figure it out in your head as well. All right. So let's let you try it for a minute. I'd like for you to pause the video, and on a piece of paper, or you can use that Google Apps that I just did with canvas.google.apps. But I'd like for you to use this number 8/5, so 8/5. And I'd like for you to try to draw a model, and if possible, see if you can reason it out either in your head or use the algorithm to try it with just numbers. So go ahead and pause that while you do that. All right, so we're going to be back, and hopefully you paused it and you've got an answer. So let's just see if you were right. So 8/5, I'm going to go ahead and let's show what that would look like. And let me get a new page here. So 8/5. Okay. So if you drew your model, you know that it's broken up into 5 pieces because the denominator says we have 5. 5 pieces make a whole. So I keep drawing rectangles. I need to draw circles in a minute. So there's 5 right there. So 1, 2, 3, 4, 5. But I have 8 pieces, so I need to go ahead and draw another one. Break it up into 5 pieces. And again, if we were doing this perfectly, it would be all equal pieces because fractions are equal pieces. So 5, 6, 7, 8. There's my 8 pieces. So I have 1 and 3 this. Okay, so 1 and 3 of the 5 right there. I'm doing it just with an algorithm. 8 divided by 5. So 8 divided by 5. 5 goes into 8 once. 1 times 5 is 5. 8 minus 5 is 3. So I have 1 and 3/5, which is exactly what I got with my model. Some of you are reasoning it out. You're like, okay, well, I know that 5 goes into 8 once. I'm going to have 3 pieces left over, so 1 and 3/5. So lots and lots of ways to try that. Okay. All right, let's do one more of these before we call it. And I'd like for you to try this one, which is, we did 8/5 on that one, and I just saw that this is the same one. So let's change it to 7/2. Okay, so let's do this one, and we are going to change it to, let's get a new image here. Let's do 7/2. So go ahead and pause this video while you try and do that one, please. Okay. All right, we're back. So hopefully you solved this a couple different ways. So let's draw the model first. We know we have 7 pieces out of a half, And so I'm going to go ahead and do those circles this time just to be different. I'm going to try this. So I need 1, 2 pieces, 3, 4 pieces, 5, 6 pieces, and 7 pieces. So what is this? This is a mixed number. I have 1 whole, 2, 3, 3, and 1 half. This could be pies, it could be pizzas, whatever works. You're doing it with an algorithm, so we've got 7 divided by 2. So 7 divided by 2. 2 goes into 7 3 times. 3 times 2 is 6. Subtract 1 left over. So we have 3 and 1 half. Either way works. For those of you who are trying to reason it out, you know that 2 goes into 7 3 times. 6, 1 left over, 3 and 1 half. All right. Well, I hope that helps with that. And then on the next one, we will be doing it from the other way around. We're going to start with a mixed number and try to convert that to an improper fraction. All right. Nice job, guys.